This video is about collecting like terms in algebra. So to begin with, to understand what we're talking about, imagine a family with two parents and two kids go to see a show. They could all line up at the ticket counter in turn and they could buy an adult ticket and then they could buy another adult ticket and then they could buy a child ticket and then they could buy another child ticket. But a more likely way of doing it is they'd go up to the counter and they'd ask for two adult tickets plus two child tickets. And this is collecting like terms. That's all it is. You can see that over on the left, we've got two adult tickets. We've got an A and we've got another A by themselves. And on the right-hand side, we've collected them together to say we've got two adult tickets. And on the left, we've got a child ticket and we've got another child ticket, whereas on the right, we've collected the child tickets and said we've got two of them. That's what we mean when we talk about collecting like terms. That's all it is. So let's have a look at some more examples of it. Let's suppose that I had a Christmas tree plus another Christmas tree plus another Christmas tree. Well, what have I got? It's easy, right? I've got three Christmas trees and I can just write it with a 3 and then a Christmas tree to mean I've got three Christmas trees. In terms of the mathematics, what I'm really saying is I've got three groups of one Christmas tree. So actually, there's an invisible times sign in there, but I don't have to write that when I'm using algebra. I can just write 3 tree, and I know that I mean 3 times tree, and so does everyone else. Now let's have a look at another example. This time, let's suppose that I have a Christmas tree and I want to add a carrot to that. So I've now got a Christmas tree and a carrot. But then I'm going to subtract a Christmas tree and I'm going to add 2 carrots. Let's collect like terms on this and see what we end up with. So you can see that I have some trees and I have some carrots. The like things are the trees are alike, and the carrots are alike. So let's start with the trees. I have one tree, and then I subtract one tree. So actually, I'll have no trees. And now let's have a look at the carrots. I've got one carrot plus 2 more carrots. So I'll have 3 carrots. I don't have to write that 0 trees after I've collected like terms. I could also say that I've got no tomatoes or no bananas, but I don't bother writing that, and so I don't have to write that I've got no trees. I can simply say that after I've collected like terms, I'm left with 3 carrots. Now, in mathematics, there is nothing stopping us using Christmas trees and carrots or any symbols that you like. But normally we use letters that are on the keyboard simply because it's so much easier to type them in and faster to write them. So let's have a look at some examples using letters. Let's try that same one again. So using letters this time. I had a tree and then I added a carrot and then I subtracted a tree and then I added 2 carrots. This time, I've written T for tree instead of drawing the tree, and I've written C for carrot instead of drawing the carrot. What do I have? I've got a T over here on the left. Collecting like terms, the T's are alike. So I've got 1 T, and I subtract a T. That's going to give me 0 T's, and I don't have to write down that because I've got none of them. Then let's collect like terms on the C's. I've got 1 plus 1C, and I've got plus another 2C, giving me 3C. All right, let's try another slightly more complicated one. This time, I'm going to have 3 TC plus C minus T plus 2C. And I want to collect like terms and simplify this, that is, make it look simpler. The very first thing to notice is that in my first term, 3TC, I've got 2 letters. And what we have to remember is that there's invisible times signs. So this 3TC is the same as 3 times T times C. And then we've got a C by itself, and then we've got a minus T, and then we've got a plus 2C. Now the really important thing here is that 3TC is 3 lots of T times C. And T times C is not like, as in like terms, C or T. It's different. It's different. So when we go collecting the like terms, 3TC is one type of term, C is another type of term, and T is another type of term. So let's collect all the like terms. We've got 3 lots of TC. Then let's have a look at the C's. How many C's do we have? We've got plus 1C. You can see I've just written plus C. There is an invisible one in there that we don't bother writing. I've just got one of it. So I've got 1C there, and I've got 2 more over here on the right. So that gives me 3 C's. And I've got minus 1T. And so when I collect like terms on this expression, I get 3TC plus 3C minus T. Often, when we're using algebra, when we're working with letters, we write them in alphabetical order inside each term. So you'd be more likely to see an answer of 3CT times 3C minus T. It doesn't actually matter because when I multiply, I can put my numbers in either order and get the same answer. 3 times 4 is 12, and 4 times 3 is also 12. So in the same way, T times C is the same as C times T. Let's have a look at some more, getting a little bit harder. This time, we're going to have a look at trying to collect like terms and simplify something that looks like 4x squared plus x. And this time you can see that we've only got x's in both of our expressions. However, is x squared the same as x? Well, x squared is actually equal to x times x. And so 4x squared is the same as 4xx. And just In the last example, when we had t times c, wasn't like t and it wasn't like c, x times x is not the same as x. It's not the same kind of term as x. So when we see x squared or x cubed or x with any little number above it, those numbers have to be the same, those indices have to be the same for the terms to be alike. So actually we can't do anything at all with this. We can't collect anything and we can't make it simpler. It's just going to stay at 4x squared plus x. And that's really everything there is involved in collecting like terms. Let's have a look at a really tricky example, and you'll see that it's not so tricky after all. 4x squared plus 7xy minus 2y minus 7x squared plus 3y plus 4xy plus 8y squared. The trickiest thing about it is the sheer number of terms. So we'll start by finding things that look like each other. Our first term is an x squared. So let's have a look through and see if we can find any other terms that have x squared and nothing else. There's one here, minus 7 of them. So let's collect those. So I've got 4 minus 7, which is minus 3x squared. All right, what's next? The next term in my list is xy. Are there any other xy's? Yes, over here I can see a plus 4xy. So I have a plus 7xy and a plus 4xy, which gives me 11xy. Then I have a y, just y by itself. And here I've got y by itself. So I've got minus 2 of them, and I wanted plus 3 of them. That will give me plus 1 of them. And I don't have to write the one in front if I don't want to. I can just write it as y. It says I've got a y, a single y. And then lastly, who haven't I underlined? I've got this 8y squared here, plus 8y squared. There's nobody else, no other terms in y squared, so I'm simply going to write that as plus 8y squared. And there we've collected the like terms.